We are starting now the topic of differentiation for A2 levels from the past papers. It is question number 1. The curve with the equation y equal to e sine of e2 of x into sine of x plus 3 cos of x has a stationary point in the interval from x lies between 0 to pi. Find the x coordinate of this point, giving your answer correct to the two decimal places. So y equal to e power 2 of x sine of x plus cos of 3 cos of x. And we're going to find out the stationary point from 0 to pi value. Since this is the equation in which we are going to find out the stationary points, we know that for the stationary points, dy by dx is equal to 0, and you will get the points of x coordinate of this equation there. So first we will find dy by dx for this. It is the product of two different functions, u and v there. So it means the derivative of this thing will be equal to v into u derivative plus u into v derivative. So dy by dx is equal to v, that is sine of x plus 3 cos of x as this into derivative of e power 2 of x, that is e power 2 e power 2x, because 2x derivative is 2 into e power 2x plus u as this e power 2x as this and v derivative. So sin x derivative is cos of x plus 3 as this into cos derivative is minus sin of x. Now we will put this equation equal to 0. So e power 2x is common. It is 2 into sin of x plus 3 cos of x plus cos of x minus 3 sin of x. That thing is equal to e power 2 of x 2 sin of x plus 6 cos of x plus cos of x minus 3 sin of x. Now, this thing is equal to e power 2 of x into 2 sin of x and minus 3 sin of x will become minus sin of x plus 6 cos of x plus cos of x, that is equal to 7 cos of x. Now, you put that thing equal to 0. So dy by dx, if it is equal to 0 for the stationary points, then e power 2 of x into minus sin of x plus 7 cos of x equal to 0. But we know one thing, that e power 2 of x cannot be equal to 0, because anything power e is not equal to 0. Then minus sine of x plus 7 cos of x is equal to 0, or sine of x equal to 7 cos of x, dividing on both sides by cos of x. So sine x over cos of x is equal to 7, or tangent of x is equal to 7, because sine x over cos x is equal to 7. We know one thing, that tangent is positive in the first and the third quadrant, but our range is given there equal to 0 to pi there. So only first value will be accepted there, because third quadrant is out of the range of this interval there. So x will be equal to tangent inverse of 7, and that thing will be calculated as 1.43. Radians is the answer for this question, for the part A of this, where we are going to find out the x coordinate of the stationary points. Determine whether the stationary point B part, whether the stationary point is maximum or minimum. So what we are supposed to do it here, for the maximum or minimum, we use the second derivative of that. If that derivative is less than 0, then it is maximum, and if it is greater than 0, it is minimum. Now we will calculate the second derivative of this function there, whose first derivative is being calculated as e of 2x 7 cos of x minus sine of x. So we can write it here. So second derivative of this. Again, it is product of the two functions u and v. So that thing we can write it as 7 cos of x minus sine of x into 2 e power 2 of x plus e power 2 of x as this, and that will become 7 minus sine of x minus sine of x derivative is cos of x. So that thing is equal to 7 cos of x minus sine of x into 2 e power 2 of x plus e power 2 of x into minus 7 sine of x minus cos of x. Now we put in this interval the value of x there equal to 1.43 into this. So that will become 2 into e power 2 into x power is 1.43 multiplied by 7 cos of 1.43 minus sine of 1.43 plus e power 2 into 1.43 into minus 7 sine of 1.43 minus cos of 1.43. After doing this calculation, you will see that the answer for this question is less than 0. So it is maxima for this position here. So this is question number 1 of the topic of differentiation from the past papers.